Let's begin with a question. Have you ever wondered how your electric vehicle charges so fast, or how a wind turbine converts the breeze into usable electricity? Behind these wonders are semiconductor devices, tiny yet powerful tools that have revolutionized power electronics. 2.1 Introduction. Semiconductor devices are like the brain and heart of power electronics. They help control and manage the flow of electricity in electronic systems. Imagine your home's electricity system as a water pipeline. Semiconductors act like valves, opening and closing to control how much water, electricity, flows to each device, making sure everything works efficiently. 2.2 Semiconductor devices in renewable energy systems. Renewable energy systems use sunlight, wind, and other natural sources to generate electricity. But this electricity needs to be converted and controlled to make it usable. This is where semiconductors come in. Solar panels and inverters. 1. Solar panels produce DC electricity, which needs to be converted to AC electricity for home appliances. 1. This is done by an inverter. 2. MOSFETs, metal oxide semiconductor field effect transistors, and IGBTs, insulated gate bipolar transistors, are the key semiconductor devices in inverters. 2. They switch on and off at very high speeds to convert the electricity efficiently. Wind turbines. 1. Wind turbines generate electricity at varying speeds, depending on wind speed. 2. Semiconductor devices like thyristors and IGBTs in power converters stabilize this fluctuating power, ensuring smooth supply to the grid. Battery energy storage systems, BESS. 1. Batteries store energy from solar panels or wind turbines for later use. 2. SiC MOSFETs, silicon carbide, are used in these systems because they can handle high temperatures and work efficiently, even with large power loads. 2.3 Electric vehicles, EVs. Electric vehicles, EVs, are a perfect example of how semiconductors impact daily life. Powering the motor. 1. The motor in an EV needs a lot of power, controlled by IGBTs and SiC MOSFETs. 2. These semiconductors ensure the motor gets the right amount of electricity for smooth acceleration and efficient energy use. Fast charging stations. 1. EVs need to charge quickly, especially on long trips. 2. SiC MOSFETs in fast chargers reduce heat loss and make the charging process quicker and more reliable. Regenerative braking. 1. Regenerative braking allows EVs to recover energy when slowing down. 2. Power diodes help redirect this energy back into the battery, increasing efficiency. 2.4 Industrial automation and robotics in factories. Machines are controlled to operate efficiently using variable frequency drives, VFDs, and robotics. VFDs in motors. 1. Motors power everything from conveyor belts to fans in industries. 2. VFDs control the motor's speed and torque, and IGBTs and thyristors are used to adjust the power supply dynamically. Robots in manufacturing. 1. In robotics, MOSFETs control precise movements, allowing robots to handle delicate tasks or repetitive operations with high accuracy. 2.5 Consumer electronics. Semiconductors are in almost every electronic device you use daily. Laptop chargers. 1. Inside a charger, MOSFETs regulate the power flow, making them small and efficient. 1. Without them, chargers would be bulky and waste energy. LED lighting. 1. LED lights use power diodes to convert AC power to DC and ensure consistent lighting while saving energy. Uninterruptible power supplies, UPS. 1. A UPS keeps your devices running during power cuts. 1. IGBTs in UPS systems switch quickly between battery and main power to provide uninterrupted energy. 2.6 Aerospace and defense. Semiconductors are also vital in challenging environments like airplanes and defense systems. Aircraft power systems. 1. Lightweight, efficient power systems are critical in aircraft. 1. SiC devices ensure high efficiency while keeping the system compact. Radars. 1. Advanced radars in fighter jets use Gallium Nitride transistors. 1. These handle very high frequencies and voltages, making them ideal for military use. 2.7 Emerging technologies. New technologies like smart grids and IoT, Internet of Things, rely heavily on semiconductors. Smart grids. 1. A smart grid balances electricity supply and demand in real time using thyristors and MOSFETs. IoT devices. 1. Smart devices in homes and cities use low-power MOSFETs to extend battery life, making them energy efficient and reliable. Data centers. 1. With the rise of cloud computing, data centers require efficient energy management. 1. SiC MOSFETs help reduce energy loss and improve sustainability. 2.8 Challenges in real-time applications. Although semiconductors are essential, they also have challenges. Heat management. 1. High power usage generates heat. 1. Cooling systems are needed to prevent devices from overheating, adding to the cost and complexity. High cost of advanced materials. 1. Materials like silicon carbide, SiC, and gallium nitride, GaN, are expensive, which can limit their use in budget-friendly applications. Reliability in harsh environments. 1. In industries like aerospace or automotive, semiconductors must work reliably under extreme conditions like high heat or vibration. Summary: semiconductor devices are the heroes behind the scenes in modern technology. They make renewable energy efficient, drive electric vehicles, power factories, and even keep airplanes in the sky. As technology evolves, so do the applications of semiconductors, bringing us closer to a more connected and sustainable world.